In this presentation, we're going to look at solving rational equations. In order to solve rational equations, the first thing we want to do is determine the LCD for all terms in the equation. We're going to write each term equivalently with the LCD, and then we can cancel our denominators. We want to solve the resulting equation using either linear or quadratic techniques. Our last step is we want to check the solution. This is a required step. What we are looking for is if the denominator is 0. Remember that you are never allowed to have a denominator of 0, so if this occurs, we will discard the solution. All right, let's go ahead and look at some examples. We're going to start with one that we've already looked at before. Remember that we saw some examples of this when we talked about solving linear equations, and so let's just review what this involves. In order to solve this, our first step is to find the LCD. For this one, our LCD, the number that is divisible by 4 and 6, is 12. So in order to solve this, the first term, in order to get a denominator of 12, we want to multiply by 3. Whatever we do to the bottom, we do to the top. Same thing for 1 over 4. In order to get a denominator of 12, we multiply by 3. We'll do the same thing to the top. And for our last term, in order to get from 6 to 12, we want to multiply by 2, similarly to the top. So this becomes 3x over 12 equals 3 over 12 plus 2 over 12. Now, as we saw before, remember that since all of our denominators are the same, we can cancel them. Sorry, I forgot the x. And we have a resulting equation of 3x equals 3 plus 2x. So now we want to solve. This is a linear equation. So remember, with linear equations, we want to move all of our variables to one side and all of our constants to the other. In order to do this, I'm going to subtract 2x. And our final answer is x equals 3. We don't have to worry about the denominators being 0 since all of our denominators were constants. And so x equals 3 is our solution. All right, so now let's go ahead and extend this to denominators that have variables. If we look at example B, we have 1 over x equals 1 over 5 plus 3 over 2x. So in order to find our LCD, let's start with the numbers. We have denominators of 5 and 2, so our LCD, the number part, will be 10. We also have x's in the denominators, so we are going to want a LCD to include an x as well. So our LCD will be 10x. Okay, so now let's go ahead and rewrite everything with a denominator of 10x. The first fraction, 1 over x, in order to get a denominator of 10x, we're going to want to multiply by 10. 1 over 5, to get a denominator of 10x, I need to multiply by 2 and x. We will do the same thing to the top. And for our last fraction, in order to get from 2x to 10x, we're going to multiply by 5 to the top and bottom. Okay, so if we do this, what do we end up with? We end up with 10 over 10x equals 2x over 10x plus 15 over 10x. We can cancel our denominators, and our resulting equation is 10 equals 2x plus 15. Okay, this is a linear equation. All of my variables are on the right, so I'm going to subtract 15 from both sides. I get -5 equals 2x, and we can divide by 2. Our final answer is -5 over 2 equals x. For our check step, again, all I want to know is this going to make my denominators equal to 0? If I plug into the first one, -5/2, is it equal to 0? No. For 2x, 2 times -5 over 2, again, I don't really care what it is. All I care about is if it's 0 or not. 2 times -5 over 2 is not equal to 0, and so our solution is -5/2. So these are some basic ones that we have. So now let's go ahead and increase the difficulty just a little bit. Let's start out with x plus 1 over x equals 5. All right, so what is my LCD going to be for all terms? My LCD, my denominators, I have a 2 and an x, so that will be my LCD. Now we do want to be very careful on this one, because if we notice that that first term, x, is not in the denominator. So when I do my LCD step, I want to think of this as x over 1. Okay, so first term has a denominator of 1. We need to multiply by 2x to the top and bottom. Second term, I have the x, I am missing a 2. So I'm going to multiply by 2 to top and bottom. And the last one, I have a 2 in the denominator. I need to multiply by x. If we go ahead and multiply this out, we get 2x squared over 2x plus 2 over 2x equals 5x over 2x. We can cancel our denominators, and our resulting equation is 2x squared plus 2 equals 5x. In order to solve this is a quadratic equation because I have an x squared term. So in order to do that, we want to move all terms to one side of the equation and set it equal to 0. I'm going to subtract 5x from both sides, and I'm going to write in descending order, so we get 2x squared minus 5x plus 2 equals 0. We're going to go ahead and factor this. 2x squared, I get 2x and x. Things that multiply to 2 are 1 and 2. I need to put the 2 in the second set because it cannot go in the first set with the 2x. They have a common factor. And our 1 will go in the first set. To finish off our factoring, we have a plus 2, We are multiplying 2a plus 2, so they have same signs, and they are both negative. All right, we set each one of these equal to 0. We get 2x minus 1 equals 0, or x minus 2 equals 0. The first equation, if we go ahead and solve this, I can add 1 to both sides and divide by 2. So we get x equals 1/2. My second equation, I can add 2 to both sides, and we get x equals 2. All right, so if we check, remember again, we're just checking, is my denominator going to be 0? X equals 1/2. Is it 0? No. So we are okay there. Same thing with x equals 2. 2 is not equal to 0. And so for this equation, we have two solutions, x equals 1/2 and x equals 2. All right, let's try another example. We're going to get a little bit more complicated now. And so, but even something like this is not going to be that bad. All right, so let's figure out our LCD. Our LCD, what is in the denominators? Our LCD is going to be x plus 1. All right, so for the first one, if we go ahead and do this, we already have an x plus 1 for a denominator, so we are okay there. 4, I'm going to treat it as 4 over 1. And we do not have the denominator. We have a denominator of 1. So I'm going to multiply top and bottom by x plus 1. And the last one, we have 8 over x plus 1. Again, we have the denominator of x plus 1 already, so we don't have to do anything to this one. Okay, so we go ahead and multiply. We get 8x over x plus 1 equals, I'm going to go ahead and distribute. We get 4x plus 4 over 1 times x plus 1 is x plus 1 minus 8 over x plus 1. Now that we have same denominators, we can go ahead and cancel them. Our resulting equation, it is 8x equals 4x plus 4 minus 8. If I combine like terms, I get 4x. 4 minus 8, we have different signs, so we're going to subtract and keep the sign of the larger number, giving us negative 4. This is a linear equation, so I'm going to move all of my variables to the left. And we get 4x equals negative 4. I can divide both sides by 4, and we get x equals negative 1. All right, our check step. If I plug this into my denominator in the first one, negative 1 plus 1 is 0. So I cannot keep this as a solution because remember, we are never allowed to have denominators of 0. So if our only solution, or let me go ahead and say this first, we actually have a special name for this. This is called extraneous. And basically extraneous, what it means is that you didn't do anything wrong, it just doesn't work in the original problem. Okay, so what do we need to know? What we need to know is if our only solution doesn't work, then what is our answer? Our answer is no solution. All right, let's try a couple more. This here is going to be the hardest one that we have to work with. In terms of everything that's going on, it looks the most complicated, but we're going to see that it's actually not that bad. So the first thing that I want to do on this problem is I want to go ahead and factor the denominators just like we did before when we talked about adding and subtracting. X squared minus 9, if I factor that, that is x minus 3, x plus 3. So now what is our LCD? In terms of our denominators, we have denominators of x minus 3 and x plus 3. This covers everything. So let's go ahead and multiply by this. So our first fraction already has our denominator of x minus 3, x plus 3, so we can leave that one alone. Our second one, we are missing the x plus 3, so I'm going to multiply by x plus 3 to the top and bottom. And my last one, I am missing x minus 3. So I'm going to multiply by x minus 3 to top and bottom. From here, I can cancel all of my denominators. And let's see what our resulting equation is. We have 3x. I'm going to go ahead and distribute or clear the parentheses. 1 times x plus 3 is just x plus 3. And 3 times x minus 3 is 3x minus 9. We can combine our like terms. We get on the right 4x plus 3 equals 3x minus 9. This is a linear equation, so I'm going to subtract 3x from both sides. We get x plus 3 equals negative 9, and I can subtract 3 from both sides. And we get x equals negative 12. All right, if we check this, negative 12 squared plus 9, is that going to be equal to 0? The answer is no. Negative 12 minus 3, is it 0? No. Negative 12 plus 3, is it 0? No. And so we have that our solution is x equals negative 12. So this is the hard problem. Let's go ahead and look at some other ones that are going to be special cases. The last ones we have are going to be special cases because these are technically proportions. Remember that a proportion is when a fraction is equal to a fraction. So for this one, we don't actually need LCD. What we're going to do is cross multiply. This is only allowed when you do have one fraction equals another. So if we cross multiply this, we're going to get 6 times x minus 2 equals 5 times x minus 3. We can go ahead and distribute. We get 6x minus 12 equals 5x minus 15. This is a linear equation. I don't have any squares, so I'm going to move all of my variables to the left. We get x minus 12 equals negative 15. And then I can move all of my constants to the right. And we get x equals negative 3. All right, check step. Negative 3 minus 2, is it equal to 0? No. What about negative 3 minus 3? Negative 3 minus 3 is actually equal to negative 6 because they have same signs, and so we have that is not equal to 0 either. So our solution is x equals negative 3. All right, last example. Let's look at x over 3x minus 10 equals 2 over x minus 3. This is also a proportion, so we can go ahead and cross multiply. I get x times x minus 3 equals 2 times 3x minus 10. All right, if we distribute, we get x squared minus 3x equals 6x minus 20. All right, this is a quadratic equation because I do have an x squared term. So I'm going to move all of my terms to one side. I'm going to subtract 6x and I'm going to add 20. If we do that and combine our like terms, we get x squared minus 9x plus 20 equals 0. I can go ahead and factor this. X squared is x and x. Things that multiply to 20 and combine to 9 is 4 and 5. We are multiplying to a positive 20, which means same signs. We are combining to a negative 9. Both will be negative. All right, we go ahead and set each factor equal to 0. And solve. First one, we can add 4 to both sides. We get x equals 4. Second one, I can add 5 to both sides. And we get x equals 5. All right, so now let's check our answers. If we plug into the first one with the 4, 3 times 4 is 12. Minus 10 is 2. It is not 0. 4 minus 3 is 1, not 0. So we can keep our first solution. What about 5? If we plug in 5, 3 times 5 is 15, minus 10 is 5, not 0. 5 minus 3 is 2, not 0. And so we can go ahead and keep our second solution. That takes care of solving rational equations.